Question number 13, total internal reflection. When a ray travels from denser medium to rarer, it is termed as refraction. And what we have covered is, this is glass, a ray. When this ray travels from one medium, glass, this is angle of incidence. This is air. When ray travels from glass to air, it was termed as refraction, and this angle was R. Refractive index of glass is more than that of air. That is why the value of R comes out to what? More. If this angle is 45, this is say 60. When this is 50, say this is 70. This is 1. Now, we will keep on increasing this value. Angle of incidence 20, 30, 40, 50, 60, 70. We will keep on increasing this value. If you keep on increasing this value, then it is possible after some time for certain value of angle of incidence, this angle R may come out to be 90 degree. For certain angle. If you further increase this angle, then what? If you further increase this angle, then the ray comes back to the same medium, that is the glass. This face behaves as if it is a mirror. This phenomena is known as total internal reflection. This angle is termed as theta critical. So, if angle of incidence is more than theta critical, ray comes back to denser medium. In this case, it is glass. This phenomena is known as TIR, total internal reflection. What is the condition for theta critical? Yes, this material is a refractive index nu. Nu, Snell's law, nu into sine theta critical is equal to what? It moves to the other medium. This is what? Air. For air, nu for air is equal to what? 1. So, for one medium, it is refractive index of the medium nu into sine of angle theta critical is equal to what? 1 into sine of R in this case is 90. So, nu into sine theta critical is equal to 1. Sine 90 is also 1. Sine theta critical is equal to what? 1 by nu. So, once you find theta critical, suppose for some it comes out to be say 42 degree. If it is 42, it is this diagram. The moment you increase this angle from 42 to 43, the ray comes back to the same medium, that is in this case glass. This phenomena is known as TIR, total internal reflection. 2 marks question board. What do you mean by the term TIR, total internal reflection? What is critical angle, theta critical? And you have number of objective questions. 3 minutes with you to write. Sin theta critical is equal to 1 by nu. Nu means nu relative. Here nu of glass with respect to water, with respect to air. Nu of air is what? 1. That is why we are writing for nu only. Numerical. Numerical number 9. You can just write it as one line only. Need not open the book. Numerical number 9 statement is calculate speed of light in a medium whose critical angle is 45 degree. I repeat the statement, calculate speed of light in a medium whose critical angle is 45 degree. Given is what? Theta critical, 45 degree. Find what? Speed of light in the medium. 1 minute with you to try. Formula is written on the board. Yes, one concept, sin theta critical is equal to 1 by nu. This is one equation. 2, yes, nu is equal to what? Speed of light in free space, 3 into 10 to the power 8 divided by speed in medium. From these two equations, what you get is sin theta critical is equal to 1 by nu. Nu is equal to what? 3 into 10 to the power 8 divided by V. You can shift it to numerator. Sin theta critical, sin 45 degree. Sin 45, if you put theta critical equal to 45 degree, sin 45 is equal to what? 1 by root 2 is equal to 3 into 10 to the power 8 into V. V is equal to what? 3 root 2 into 10 to the power 8 meter per second. Comes out to be equal to what? Yes, 3 into 1.414, approximately 4.2 into 10 to the power 8 meter per second. Correct? Sorry. This is 3 by root 2, sorry. It is 3 by root 2. 3 not into 3 into root 2, 3 divided by root 2. Comes out to be what? 2.14 into 10 to the power 8 meter per second. B part of question number 13 deals with TIR, applications, examples and applications. TIR, examples, applications. Number 1, example or application number 1 is white light. This is white light. Means what? Made up of all colors. If it moves from one medium, say glass or water, to air. Then R, angle which the refracted ray makes with the normal R, depends on what? Suppose this is angle of incidence I, nu into sine I is equal to 1 into sine R. Sine I is same for all colors. Violet, indigo, blue, green, yellow, orange, red, all colors are there. All wavelengths are there. Refractive index lambda. Yes, for violet. This is for red. At this point, nu is maximum for violet. So nu is proportional to sine R. Nu is more for violet color. So R is more for violet color in comparison to red color. That means what? When you actually see this, you will get this is violet color, angle R for violet. This is red, R for red color. If you keep on increasing this angle, yes, which color will undergo critical TIR first? Yes. If you turn this ray up white, it will move like this. First color to suffer TIR is violet color. So if there is an observer, observer 1 inside the medium, inside water, will observe what? If you keep on increasing this angle, violet, observer 1, yes, will observe TIR of violet first and red color last. This is observer 1, O1. What about other observer here? What is the observation of observer number 2? Yes, if you keep on increasing, theta is equal to 0, you have to increase it like this. Competition, you get this part also, angle will decrease. But here angle of incidence is 10, 20, 30, 40. Yes, observer 2 will observe what? Observer 2 will miss the violet color first. Agreed or not? The moment TIR takes place, violet color is inside and will miss the red color last. 3 minutes with you to write. 3 minutes with you to write. Simple words. You can say, if I increase this angle, this is how the two rays will move. TIR takes place for violet first. At this stage, suppose TIR is taking place for violet. So where is the violet color? Inside. Where is the red color? Outside. TIR will take place for all, but will take place first for violet color, because nu is different. Nu is maximum for this one. Mirage effect. Mirage effect is desert areas. This is ground, that is horizon flow. So this is the effect which you observe in desert areas. In desert areas, suppose there's an object, a tree, and there is a point A. So there is an observer. My eye say, this is how eye is positioned, observer. You see an object directly, that is as simple. So you see a tree, that's normal phenomena. But in desert area, other than this, you have one more observation. Nearby earth, temperature is high, that is why density is low. Here, it is density is high. As the ray starts from here, that is point A, it is moving from denser medium to rarer medium. Here it is high density, here it is low density. This medium is what? Denser. This is what? Rarer. So in the previous one, ray was moving from glass to air, from denser to rarer. As this ray moves from denser to rarer, this TIR takes place. This ray traces this path. And to the eye, to the observer, this ray appears to be coming from different point. That is, and what you observe is A dash. Means what? This observation that there is an object and its image, generally you have your orientation of the brain or such data that there is some water available. Agreed or not? When you see this object, you say that in desert area there is a lake. But when you move close, there is no water. It is an optical illusion. Mrig Trishna. So, it means what? That an observer will find a tree and its image and comes out with an assumption as if there is some water, but there is no water. This is known as mirage effect. This is one. It is in desert areas. One, near surface, temperature high, density low. So it becomes what? Rarer medium. Above surface, temperature is low, density is high, it becomes a denser medium. So the ray moves from denser medium to rarer medium, so it undergoes TIR. Time with you is 2 minutes. Board question, 2 marks, mirage effect. Looming. It is in polar areas. In polar areas, the phenomena is like this. Airports. So there are aeroplanes. This is aeroplane A. it is parked in parking area. In polar areas, this floor horizon is at low temperature. So this is low temperature means what? This is high density. Air nearby is high density, and here it is low density. So suppose there is an aeroplane landing. So pilot I will observe this aeroplane directly because it is parked there. At the same time, what you observe is a ray from A starts. It is moving from high density to low density, and TIR takes place. And this observer finds as if the ray is coming from a different point and finds A dash means what? Image. This is the object and image. That means what? You have 5 aeroplanes parked, and at the same time you find 5 aeroplanes in air also. That is why it becomes very complex for this pilot at the time of landing and when you have to take off, because you will have to pass through some image and sometimes it is a real plane. That is where the issue is. So near surface temperature is, yes, near surface temperature is low, density is high, medium is denser. Above surface it is, temperature is high, density is low, medium is rarer. Simple. Here density is high, it is denser medium, it is rarer medium. When the ray is moving, it is moving from denser to rarer. That is why TIR takes place. 1 minute to draw the diagram only. 1 minute to draw the diagram. Deviation by 90 degree means what? Suppose you want to turn a ray by 90 degree, then what? Take a prism, a ray of light. Suppose it is A, B, C. Suppose a ray of light is incident. On this face, it is normally, it will pass as it is. Why? Angle of incidence is 0. Angle which the ray makes with the normal to the plane. So 0, it will pass as it is. At this point, the angle of incidence is I. If I is more than theta critical, then what? TIR will take place and this ray will turn as it is. This angle of incidence is equal to angle of reflection, and this phase AC behaves as a mirror reflecting surface, and the ray, suppose it is direction number 1, ray number 1, it turns to a new direction 2. It has turned by what angle? 90 degrees. Suppose this I is 45, this is also 45. If I is 45, 2I is 90 degree. Ray turns by, yes, 90 degree. This is one. Equivalent, almost same application, deviation by 180 degree. Again a prism, A, B, C. Suppose these angles are 45 degree. A ray number 1. Why it passes as it is? Angle of incidence is 0 on this face AC. When it hits face AB, then this angle of incidence I, suppose it is more than theta critical. If it is more than theta critical, TIR takes place. So I is equal to R. This angle is also I. And face AB behaves as mirror. At this point, yes, again, angle of incidence, suppose I is more than theta critical, then again TIR will take place and this face BC acts as a mirror. So this ray moves at what angle? It moves again at angle I. That means if I is more than theta critical, TIR takes place. Where? At face AB and BC. Ray number 1, when it moves parallel to itself, moving back 1 and 2, yes, turns, ray turns by what angle? 180 degree. One more application. Fiber optic. All of you have heard about this. Phenomena is, yes, material, just like glass you have material, fiber optic material, plastic. You might have seen some of the decoration pieces, there is a thin wire and at the end of the wire you have a fiber optic illumination source. You might have seen some of the decoration pieces, they appear to be plastic wires. They are actually fiber optic threads. In fiber optic, the ray enters from one end such that angle of incidence I is more than theta critical. So TIR will take place, this face will act as reflecting surface. So it moves to the other surface, again TIR takes place, again TIR takes place, and this is how the ray moves from say face 1 to face 2. Hardly any loss of energy there. Phenomena is intercontinental, that is, one side is India, the other side of the cable is Australia. So you flash light on this side on, that light travels to the other side. That means what? If you switch on light, it is 1. So what is transferred to the other side? 1. Then there is no light for some time, means 0. There is 0. Then suppose there is light for 1 second, light for 1 second. So on the other side also you get light for 1 second, light for 1 second. So you are transferring what? A code 1011. You can get its equivalent decimal also. You can get its equivalent alphabet also. That means you are transferring what? Data. This is how data is transferred on internet through fiber optic cable.